Hey, it's John from Tinderbox Arts. So a little quick video here on oxygen sensors or Lambda sensors if you're from the UK. They all work the same way whether you're driving a car, a truck, a motorcycle, whatever it is. They're all exactly the same. They work the same way. And the point of an O2 sensor or Lambda sensor is to give the computer a reading on the oxygen level in the exhaust so that the computer can adjust the air-fuel mixture. And it would do that for two reasons. One, for emissions, so to keep emissions down, but also for performance. So when you look at an oxygen sensor, it isn't necessarily just for an emissions thing. So a lot of people try to remove them. Some computers are using it also for performance as well. So keep that in mind if you're thinking about removing one. All right, now oxygen sensors do have some different designs in one sense here. So I'll show you some other bikes in a second, but this particular one right here has 3 wires, but you may see oxygen sensors with 1, 2, 3, 4, and I think there might even be a 5-wire sensor for different reasons. Now the point of this is that an oxygen sensor, the way it's constructed, it needs heat in order to work correctly. So it's always mounted in the exhaust, pretty close to where the exhaust is coming out of the cylinder usually. And you will sometimes, like on cars, you'll see sometimes 4 oxygen sensors in a car, where you'll have 2 before the catalytic converter and 2 after the catalytic converter. And in that case, it's trying to measure, the effectiveness of that converter. But on a motorcycle, usually you have 2 or sometimes 1, or sometimes 1 for each cylinder. But in any case, you'll see different amounts of wires going to the sensor. So the different wires are for these reasons. If you have a single wire oxygen sensor, that has a signal wire, and that's just a voltage being applied to that wire, and then it uses the exhaust system itself as a ground back to the battery. That's a single wire O2 sensor. If you have 2 wires, then has a signal wire with the voltage, and then has another wire which acts as the ground. So it doesn't use the exhaust as a ground, it has its own ground, which is usually more reliable. If you have a 3-wire or a 4-wire, that has a heater built into the oxygen sensor itself. So you have 1 wire for signal, 1 for ground, and then another one for a heater that's built into the oxygen sensor, and that heater may also have its own ground, which is the 4-wire. And the point of that heater is that it wants to heat up this sensor quickly, so when you first start up the bike, it starts heating that sensor for you rather than waiting for the exhaust gases to heat up the sensor. And that gives you a more accurate reading immediately rather than having to wait 4 or 5 or 6 minutes for it to heat up. So that's just a different design philosophy, but they all work the same way. And the way the signal works is the computer wants to see a voltage between 0 and 1. So as this sensor is measuring the gases, it's going to vary that voltage back to the computer, and the computer interprets that voltage change as different oxygen levels in the exhaust system. So typically you're going to see the reading is somewhere in the middle of that 0 to 1 volt range. You're going to see 0.4 to 0.6 or to 0.7 or 8 sometimes, but you don't normally want to see an extreme in that. So it's normally somewhere in the middle there. And if the sensor is working correctly, you're going to see, as you blip the throttle or change RPM, you're going to see the oxygen sensor respond if you're reading it on a meter. And an oxygen sensor can also sometimes be working, but not working very well. So those are sometimes called lazy oxygen sensors, and basically the sensors become kind of mucked up inside, and it doesn't respond quickly to changes in the exhaust. But you do want to see it respond quickly. So if you're looking at a meter and you're blipping the throttle and you're not really seeing the oxygen sensor respond quickly, there's a delay and it's kind of slow, that could be a problem as well. So even though it's working, it's not working well enough for the computer. So basically, the oxygen sensor has a signal wire that's important to you as far as testing it, and it needs to see a voltage between 0 and 1, and we want to see typically somewhere in the middle, and we want to see a quick response. Those are the things we're going to be looking for as we actually test one of these. Now here on the Triumph Bonneville, the oxygen sensor is located again. Here's the exhaust, here's the sensor, and then this is also a three-wire sensor there, and there, of course there's one on the other side. It's always a duplicate. Now here on the R1200 RT, which is similar to the GS, the oxygen sensor, here's the cylinder head, right? Here's the exhaust that comes out, and the oxygen sensor is right here. Now this one is a three-wire sensor. Now here's a Yamaha FC09 or MT09, same thing. Again, here's the exhaust coming out, and it has a sensor right here. This is a 4-wire sensor. Here's a Triumph Tiger 800, and the O2 sensor is buried behind this little guard here. So that's a little difficult to get to, but it is there. Now, you're not looking at a bike here. This is an old Jeep Wrangler from the, it's actually a 1990. And if you look down here, I'm going to bring down to the exhaust here to get, here's the oxygen sensor here. Whoop, where am I? There. So it looks exactly the same as a motorcycle because it is the same as a motorcycle. Oxygen sensors, whether it's automotive or motorcycle, they're all going to be basically the same, and they all look the same. Before I get too much further into this, I'm going to focus on testing these things, and we'll be testing them in the vehicle or the bike itself. However, I just want to mention, if you do need to remove one of these to replace it, there's two ways of doing it. There's just you can see the hex nut there, which is part of the sensor itself. Ideally, you'll remove the connection to the computer, the wiring here, and then take a box wrench or a spanner and slip that over the wiring so that you get this connected on the nut here. And then because this is an exhaust system, it gets hot and these things tend to get ornery trying to take them out. So ideally, you have that box wrench around it, and you just give this end of the handle a whack with a hammer or your hand, and that will usually loosen it. I don't recommend using a long pipe or something like that because you may distort the exhaust or even break off this connection to the exhaust, which is welded on here. So ideally, you get a box wrench on there, give the end of the handle a good whack or a few good whacks, and that'll loosen this. And then when you put the new one back in, it usually comes with a little bit of a anti-seize, copper-based, usually anti-seize on the threads, and that'll help for the future getting this out. The other thing you can do is they do make a special tool, so if you can't get a box wrench around the socket, you can buy one of these tools, and this has an area right here to slip over the wire, and then kind of a socket here, and then you put your socket wrench on this part right here, and that they work pretty well, but the box wrench is my first choice if I can. Now, as far as testing these in the bike, there's two methods you can use. One is just a regular meter, and we just need a voltmeter, and any old thing will do. It doesn't have to be particularly special. Digital is fine, and I'm going to show you this. I think I'll actually test this in a car just because it's easier to get to, but you can use just a regular voltmeter. The other method would be to use software on a computer or on a phone sometimes that's connected to your bike so you can see what the computer is seeing. And in one sense that's superior only because you are seeing what the computer is seeing rather than what a meter is seeing, because there are other areas in the wiring that could be a problem that you could catch if you're looking at what the computer is seeing rather than what the meter is seeing. But if you're going to use a meter, all we need to do is connect it to the signal wire, and that's it. If you're going to use the computer, then you need to have the software available to do that. So I'm going to show you here on my Triumph. There's free software available called TuneECU you can use. I'm going to show you a BMW, and there's different software for that. I'm going to use a special device for that. All right, first up is, I'm going to use this Jeep as an example just because it's easier, but I swear to you, they're exactly the same. So I look under here, there's my oxygen sensor, here's the wires coming out, but it has easier access. So here are the wires from the oxygen sensor, There's two white, a black, and a gray. I'm suspecting the gray is the signal wire, but I'll just keep checking until I find the right one. I am going to ground to the battery first. However, you may want to use the ground of the sensor itself if you're checking the sensor, because that could be bad. So, just something to keep in mind. But for now, I'm going to use the battery. So I'm going to use a piercing probe so I don't have to disconnect anything. Let me show you what that looks like. If I come back out here, this is a piercing probe. And, so the way they work is you squeeze this, and that opens this up. Well, let me get that in focus. There we go. And there's a little pin in there that pierces the insulation of the wire. So that allows me to connect to the wire here without really destroying anything. And I have my meter set up, or I will shortly here. Now this engine is cold, so I'm starting this up cold. It's a 4-wire sensor, so we know it is heated, so it should start heating pretty quickly. Nevertheless, I expect to see some changes as the engine heats up. Okay, I gave you a chance to watch some of that stuff, and the engine got a little bit warmer. It's only been running, 5 or 6 or 8 minutes, but it's enough to get warm. And you see there, this oxygen sensor is not doing well. So this is actually a good illustration. You saw this thing cutting out from time to time. That is possible. That was just a connection here. Although I was playing with it and I didn't really see it change when I did. I tried several other stabs at it, and it stayed about the same. So it is possible I have a problem with the wire itself. But in any case, you saw the numbers were jumping around quite a bit, and they were down in the 200s and up to the 600s and back to. That's not normal. So, and when I blipped the throttle, it wasn't responding, so that is lazy. So this oxygen sensor is not working right. And that's a good example. If you see where the numbers are jumping around crazy like that, or it's not responding fairly quickly to the blips in the throttle, then something's wrong. So this oxygen sensor needs changing. So that was a good example. Now, if you're on a motorcycle, this is a car, but if you're on a motorcycle, it's the exact same thing. It won't look any different if there's a problem. So that was a good thing. So now I'm going to move on to some of the other bikes, and we'll try some of the software and see what that looks like. All right, now we'll test this is a Triumph Bonneville, and I'm connecting to the diagnostic connector with this cable here, and I'm using the computer. I'm not connected yet. And I'm using TuneECU, which is a free software you can get. They also make a version for phone now, Android I think it is, but I'm using this on a laptop. All right, I had to turn the engine off here to even talk. So, actually, I'm seeing some things here that I'm not super thrilled about. So, I got to figure out which side is which. There's two sensors on this bike. This one, you would have noticed, seemed a little bit odd. There were some odd readings in there. Now, I don't want to read too much into this because this is software, and there is a delay in getting from the computer through the cable into the computer and the software reading it. So, it's not an immediate reaction like a meter is. So you got to be a little bit careful there. But, as I first turned it on, the voltage was very high, over 1 volt, which is fine because, I just turned it on, everything was cold. But then as the engine started to warm up a little bit, I started getting normal readings in the middle there. But this one, I don't know if I want to call it lazy, but it was just jumping around a little bit different than this one was, and a little bit more than I would want to see. So, given the results that I'm seeing here, I might want to put a meter on that particular oxygen sensor and see what the meter says. And if I'm getting oddball readings from the meter, from the voltmeter, then I might want to change that out. But honestly, if you're going to change one, you're going to change both because they are, the same age. And I would expect, the other one to go bad soon too, if it is bad. So I'm not saying this one's bad, but it is a little bit odd. So I want to check that a little further with the meter to make sure I know what I'm looking at there. All right, now we'll try a different Triumph. This is a Triumph 800 XC. And I got to get connected here, but I'm going to use the same software for this setup. The Triumph bikes, a lot of them can use this software for free. So we're going to get this set up and we'll take a look. All right, the last one we'll test will be the BMW R1200 RT. All these BMWs with this engine are very similar. In this case, we have two oxygen sensors, or Lambda sensors, as they would call them. I'm using the GS911 tool, which connects to the computer and back to the laptop. And we'll take a look at this. Now, again, I'm looking at this cold, so it will change quite a bit as it warms up. All right, on this BMW, some interesting things. First of all, there's a Lambda or O2 control factor, which I think is just the voltage. I got to look that up actually, but down here the voltage is what we were looking at, and it was jumping around a little bit like the first Triumph that we looked at. Now again, I got to be careful because you're reading this in a delayed form, so it's not like looking directly at a meter. But when you see things jumping around oddly, especially if one of the two O2 sensors is jumping around a lot differently than the other one, then that's probably cause for further investigation, and I'd want to look at a direct reading off of a meter. Now in this case, it wasn't quite as bad as that Triumph. They did tend to even out when I had the throttle at 2,000 RPM, something like that. So they tended to even out. However, I did see some things jumping around that were a little concerning. So I might want to put this on a regular meter and see what I find out. But in any case, that's how you look at this. You want to see, if you have more than one O2 sensor, you want to see them roughly equal out. And you want to see when you blip the throttle, or when you have it at 2,000 RPM or 3,000 RPM and just suddenly drop the throttle. You want to see that response fairly quickly here. But again, just be careful because you're looking at this, in a delayed form versus on a meter when you're looking at it at direct form. So if you have any question when you're looking at the software and it doesn't look quite right or you're not sure, then put a meter on it like we did in the Jeep, and make sure you see what you should see there. You want to see a quick response. You want to see it in the middle of the range, and you want to see it reacting correctly. So, all right, let me give you some final thoughts here. So on that Jeep that we showed with the meter, this is the oxygen sensor that came out of it, and I determined that something was not quite right with it. I'm still not sure what. So I got the new one. This new one is a Bosch, and they may look slightly different. If you're going to replace it, the important thing is the connector has to be the same, or you can buy universal oxygen sensors which have the correct amount of wires and the correct threading here, and everything else is correct, but it's not going to have the end on it. So what you can do is cut off the existing end and splice the wires back on to a universal type if you need to. But in this case, I could get the correct one. So the next question is, how do these things go bad? Well, the wires can definitely get bad themselves. So you can get cracks in the wires, you can get, breaks. You can have a bad ground, especially if you have a single wire oxygen sensor. The ground is kind of important, and that can be a problem because you're grounding through the exhaust itself. Now these tips have the sensor, it's a ceramic sensor in there that can get contaminated. So if you have a lot of oil blow by, that can be a problem. Silicone is known to be a problem. So it can get contaminated, and that is a frequent problem. And sometimes they just get old. So the rule of thumb for automotive use is 30,000 miles if you have a single wire, 60,000 miles if you have a heated style, multi-wire. But for a motorcycle, I think that's a little bit different. I would bring those down because, the exhaust on the motorcycle tends to run a little hotter, I would think. And it's a tougher environment. So whether you should replace this or not also comes down to, what is this being used for on your particular motorcycle? Like I said, emissions is definitely part of this, and that may be the issue for you. But newer bikes especially are going to use this also for some performance. So the air-fuel mixture will be adjusted by the computer depending what it sees here, and it's not just for emissions is what I'm trying to tell you. So older bikes, in the 2000s, maybe up to 2010, 2013, in that range, probably it's going to be mostly emissions, I'm guessing. But for bikes that start to get newer than that, this is going to start to get used for performance. So there are kits to take out the oxygen sensor for some bikes, but you are bypassing in a sense what the manufacturer intended to do with that computer. So I'm not sure that's really such a hot idea. The cost of these is not great. This particular one here was about $50. That's about middle of the road. You can spend $20, you can spend $100 depending on the particular model. So anyway, and then when you install this, it's going to come, like I said, on these threads, there's going to be some anti-seize compound. On this one, you see this plastic covering, which I'll take off shortly, and the anti-seize has been applied at the factory. Other times they'll give you a little tube of it, but don't use too much. You just want just enough to keep it from seizing up on you, but you don't want to contaminate anything else. If you really want to get into it, automotive scopes, higher end scopes, can tell you more exactly if a sensor is lazy, for example, if it's not updating quick enough, and things like that. But for our purposes, what I've shown you in this video is enough usually to tell if the thing is bad or good or whatever. Whether you want to replace it or not, it's up to you, but at least you know now how to test one.